So now that we've spent time solving exponential equations, we have to talk about how we're going to solve their inverses or logarithmic equations. All right, and a logarithmic equation are equations that include one or more logarithms involving a variable. So the first step in doing this is that you always want to condense if necessary. So you might have to use the power, product, and quotient rules of logarithms to condense. Once you condense and get a single logarithm set equal to a number, and this is really important, we need to have a single log set equal to a number. Once you're able to do that, you convert it to exponential form. And remember, the saying for that is the base raised to the answer equals the logarithmic number. And then, once you've converted into exponential form, you solve the exponential equation just like we did in the previous video. So let's start really easy. Let's start with this, and let's say I asked you to solve log 4x minus 3 equals 2. So the first question is do we have more than one logarithm that we need to condense? And the answer to that is no. We have a single logarithm set equal to a number, so step 1 is done. So now we're going to convert it into exponential form. So we're going to start with the base. In this case, we know it's a common log because there's no base written. So it's 10 raised to the answer, which is equal to 2. All right, so 10 squared is equal to the logarithmic number, which is 4x minus 3. All right, so we get 100 equals 4x minus 3. Now this is a simple equation that we are able to solve. We have 103 equals 4x. And then we divide by 4 on both sides, and x equals 103 divided by 4. Now, the key thing about this is with logarithmic equations, there is an additional step. And that step 4 is you have to check your solution. And what that means is to check your solution, you need to make sure it doesn't make the logarithmic number equal to a negative, 0, or 1. If it does, it's extraneous. So we would check here, and we would say log 4 times 103 over 4 minus 3 equals 2. So then we get the log of 103 minus 3. Does that equal 2? So the log of 100, does that equal 2? Well, we can rewrite this as 10 squared, and we know if the base and the logarithmic number are the same, it equals the exponent. In this case, it is true. So let's look at another example together. Let's look at solving log of x minus 3 plus log x equals 1. So the first step is condensing if necessary. And in this case, it is because we're adding two logarithms. So in order to condense, we multiply the logarithmic numbers. Now we can convert it to exponential form. So the base raised to the answer is equal to the logarithmic number. So 10 is equal to x squared plus 3x. Because we have something squared, we know the only way to solve it is either by factoring or using the quadratic formula. So I'm going to set it equal to 0. and subtract 10 to both sides. I realize I can factor this to x plus 5 and x minus 2. By doing that, I get the solutions of negative 5 and positive 2. But now I have to check. So log of negative 5 minus 3 plus log of negative 5 equals 1. So I get log of negative 8 plus log of negative 5 equals 1. This cannot happen. Negative 5 is an extraneous solution, and that's because it is making our logarithmic numbers negative. Now, that does not say that a negative number cannot be a solution. It's when you plug it in, does it make your logarithmic number negative? All right, let's try 2. Log of 2 minus 3 plus log of 2 equals 1. Well, when we get this one, we get log of negative 1 plus log of 2 equals 1. This 2 gives us a negative logarithmic number, which means this 2 is also not a solution but extraneous. So your answer here would be no solution, not possible. All right, it is your turn to solve 2 on your own. The first one is solve. Log base 2, 3 minus 2x equals negative 1. All right, and the second one I would like you to do is log 6 minus log 3x equals negative 2. Go ahead and solve those now. All right, so let's solve the first one. So the first one, we have already been in condensed form. So we are going to convert to exponential. So the base raised to the answer is equal to the logarithmic number. Okay, so 1/2 is equal to 3 minus 2x. We're going to subtract 3, and we get negative 5/2 is equal to negative 2x. And then we're going to divide by negative 2, and we're going to get 5/4 equals x. When we check, it works, and that is the solution. For the next one, we need to condense first by using the quotient rule. 6 over 3x. All right, and now we're going to convert to exponential form. 10 to the negative 2 is equal to 6 over 3x. So 1 over 100 is equal to 6 over 3x. So 3x equals 600, x equals 200, and when we check, that solution works as well. All right, that is it for today. Have a great day.